Alaskan rescue plane drops a package of emergency rations to stranded hikers. The plane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground. In projectile motion, we always get these two components. The first one is the component along the x-axis, and the second one is the component along the y-axis. But according to the problem, traveling horizontally, that means we only have a component along the x-axis. We don't have a velocity, we have a zero velocity in the y-axis. Please remember that if your velocity is zero along y-axis, that means it is on its maximum height. Now, we also have this one, 100 meters. This is the 100 meters. That will represent the height of the maximum. Now, let's answer question letter A. Now, let's answer question number A. Where does the package strike the ground relative to the point where it was released? So, we're asking for this one. Now, please remember, when it comes to projectile, they don't have the same velocity as observed, 0, 0 at 40. But they all have common time. Pareho po sila ng time. So, they have the same time. Now, when we talk about this problem, we are looking for where. So, we are looking for the range. So, we are actually looking for this one. We already know this, but we don't know the time. So, we have to derive time first. Now, how to do that? To get the time, so we can have time here, because we already have 100 meters as our height. We know G, that is 9.8 meters per second. For this one, we need to know where. So, we use this formula, or you can use the change in X. If we're talking about the horizontal, we know this value, it is given, this is 40 already, 40 meters per second, but we don't know the time. I advise that we use this formula of time because we know the maximum height. So we have here time is equal to square root of 2 change in y divided by g. So we have 2. We already know the change in y, that's the maximum height. That is, let's make that negative 100. Why did I make that negative 100? Because it's down, diba? Nasa baba siya. Okay, negative 100. Divided by the negative 9.8 meters per second squared. So, if you solve that, you will have this answer. We have t is equal to 4.52 seconds. And that is the time. But we are looking for the range, this one. Now, as you remember, the formula of that one is the change in x is equal to the velocity along the x-axis times the time. So, this is already given. I think, this is the initial along x. And we already have now the time. So, if I multiply that, I will have 180.70 meters, and that is the answer. Now, you can also use these formulas if you want to. Again, the range or the change in x is this formula. We have this is 40, but we don't really know the time, so we have to compute for the time. We can use the formula that we have here in free fall. This is 0 because this is 0. Again, we're looking for the t. We just substitute the values and then you square root it. We have this answer, same as what we got earlier. And then, if we have already time, we will now use this formula or the change in x. That's the same. And then, if you multiply, we have that answer. So, same answer, different ways of solving. Letter B, what are the horizontal and vertical components? So, we are looking for the horizontal, the Vx, and the Vy of the component of the velocity before it hits the ground. So we are looking for this and this. Now, always remember, earlier we've discussed this, that we already know this one. This is 40 meters per second. Because the problem state, it is moving only horizontally. And we assume that this is 0. Okay? Now, according to our rules here, for the x-axis, this is constant. What do you mean by constant? It means it doesn't change. So for Vx, whatever our initial is, 0, which is 40 meters per second, we always get the V final of the x as 40 again because they are constant. How about the y? In y, we have to solve it because we just know it started from 0 and the y final will follow the formulas. Okay? So, let's just check what formula is better. We can use the third formula. We started with 0 and then we solve for this one because we already know this. This is 100. So, we get the values and then we substitute them and then we will get the square root of the answer. We have this one. So, now why did I choose a negative value, not a positive value? Why? Because the graph is going down. So, since it's going down, we expect that along y-axis, it should be negative. And along x-axis, this is a positive x-axis, this should be a positive value. So, that is our final answer. We have the x and the y component. Now, if you want to combine them into what we call the resultant vector, we use this formula. Vx squared plus Vy squared. If that is required in this third one, find the angle of impact. Now remember, when we are getting the resultant vector, when we're looking for the angle, we use the following formula. Arctangent of A along y divided by A along x. And then we will just use that formula. Since we know the value along x and the value along y, now we just use that formula, arctangent. Okay, they are actually the same, but I just use theta already, and then we will get this answer. Now again, if you want to get the resultant, the magnitude, you can use this formula as the resultant vector. And that's it.